Good morning, ladies and gentlemen. Welcome to Katsina State Senior Secondary School's online connect, powered by Exponential Computers. Physics lesson for SS3 students. Week 5 or fifth week of physics class or physics lesson for the SS3 students. I, the presenter, Ismail Baraya. So for the week 5 physics lesson or physics class, here are the contents. The number one is explain static electricity. The second one is explain negative and positive electricity. And also we are to distinguish between negative and positive electricity. And we are to find the difference between the insulators and the conductors. And lastly, we are to explain gold leaf electroscope. So, for the first content is about static electricity. So, when we say electricity, firstly, what will come to our mind is that we are dealing with the charge from the electric charge, that is the terminal, the positive charge particle and the negative charge particle. So normally it originated from the electric force or electric energy. That is how the electricity come to be. So we are talking about the static electricity now. So when we say static electricity is the result of an imbalance between negative and positive charges in an object. So this is the meaning of static electricity. Okay, and let's see. We said it is the result of an imbalance, and if we say something is imbalance, we mean that unable equal. They cannot be equal. They deny to be equal. That is the imbalance between the positive charge particle and the negative charge particle. So if they are imbalanced, that means that we are going to have a static electricity. So whenever we have a positive charge and a negative charge in an object, and if that energy or that charges, the terminal, the positive charge particle and the negative charge particle, they are imbalanced. So that means that we are going to have a static electricity. So and most objects maybe like a table. So a table, it can have an imbalance of the charges, the two charges, the positive and the negative charge. Also a chair and a fasten also. Normally a fasten, we used to have a static electricity from it. And here we have some example here. And it's like for a hand, for a door knob. And if you are maybe sometime, maybe you already experienced this thing in your life or in your room or class or something or anywhere. When you are to open a door, sometimes if you are about to touch that door, or if you like touch it, you will have a shock or like a spark in your hand. You will see I see like it is like a spark or like a shock. But so that force, that force, that is the that energy or that power, it comes from the static electricity. That is how it be. So that force or that shock or that spark that you see, it is it is due to that static electricity. So this is how static electricity come to be. So maybe normally in your life you already experience this thing. So that thing or that force or that imbalance of those charges, so it is due to static electricity. So that is example number one. And the example number two is like maybe if you have in a dry season, and if you are maybe you are about to remove your cuff or to take off your cuff, you will see that your hair and the cuff and the hair is trying to follow the cuff. You will see that it is due to due to the imbalance of the charges, those two charges, the positive charge and the negative charge. It is due to them because they are imbalanced. So if they are imbalanced, that means that we are going to have a static electricity. So you will see the hair is about to come off. So it is due to the static electricity. And when we are talking about these two charges, the negative charge and the positive charge, we are talking about the electron of those charges and the proton. So you see that if they are imbalanced, then we are going to have a static electricity. Or like maybe another example is like if you sometimes in other times, if you are to touch someone, or like he's in front of you, so you want to touch him, or like you want to talk to him, so the moment you are about to put your hand on his shoulder or something like that, so you will see that you will have a spark or a shock between your hand and his body. You will see that it is due to that imbalance of those charges, those particles. So it is due to that, then you will experience a spark or a shock. So it is due to static electricity. So you see, when we say static electricity is the result of an imbalance between negative and or positive charge and negative charge, or the negative charge and the positive charge. And when we are talking about the positive charge, we are talking about the proton, and when we are talking about the negative charges, we are talking about the electron. So you see, it is due to them. So in an object, or maybe a table or something like that, or even a man, so it is due to that static electricity. So this is about static electricity. So here we are to discuss the negative and the positive charges. So you see, normally those two charges, so these two charges, it is these two particles, we normally have these two particles or these two charges normally. So and maybe in a time you will see you will have a three charges, but normally, or some of them, so most of them, it is only this positive charge and the negative charge. The third one is a neutral. So let's talk about the positive charge and the negative charge now. So these two charges, this one are the types of charges, electric charges. Normally they are the two charges of the charges, the positive charge and the negative charge. And also that the positive charge used to carry the positive, that is from maybe like, let's say, a plus sign, it is a sign, and the negative charge used to carry a minus sign. So this is indicating that it is a negative charge, and also this one is indicating a positive charge. So no, these two charges are the main types of electric charges that we are having, or that we have. So and let's see that the negative charge. And when we say a negative charge, when an object has a negative charge, it means that it has more electrons than protons. So you see, the electrons are more over, or are much in than the protons. So whenever in an object or in a particle that we have a more electron than the protons, so we have a negative charge carriers or negative charges. So if we have this kind of situation whereby the electrons are more over than the proton, then we have a negative charge carriers. On the For the positive charge, when an object has or have a proton more than the electron, that means that charges, it is a positive charge carriers, because the protons are more much than the electron. So you see, whenever we have a proton is more than the electron in an object or in a particle, you will see that we will be having a positive charge carrier, because the protons are more than the electrons. So this is about them. The negative charges, the electrons are more than the proton, but for the positive charge, the protons are more than the electrons. So this is the differences. You have to consider this thing whenever you are having this interaction, that you will know that this one is talking about the positive charge, or this one is talking about the negative charge. And when there's an identical number of positive and negative charges, the negative and the positive charges could cancel each out other, and the object could become neutral. So this is what we are talking about. We will be having the three kind of charges, whereby we will be having a positive charge, the negative charge, and the neutral. So this neutral, you see, it did not have a positive charge, and also it don't have a negative charge, so it is neutral. So this is also another type of electric charge, but normally it is these two, the positive charge and negative charge. So this is about the charges, the positive and the negative electricity. So this is about them. So here we are to differentiate between those two charges or those two ions, the positive charge and the negative charge. This is here we are about to talk about their differences, how they come to differ. Okay, and let's talk about the positive ion or the positive. And the positive ion, it says that a chemical species that carry a positive electrical charge is the positive ion. So you see, this is one is talking about the positive ion, and the negative charge, it says that a chemical species that carry a negative charge. So also this is the differences. This one, it is positive ion and it carry positive electric charges. This one is a negative ion, it carry a negative electrical charge or electric charge. It's all the same thing. So also the differences number 2, it says a positive ion form when an atom or a molecule loses an electron. So you see, just like the explanation we just finished now, the positive ion, when an electron loses an electron, so you see it will be a positive ion. Also the negative ion, it says that when form it says forms when an atom or molecule gains an electron. So you see this one, the positive ion is talking about when an electron are gaining. That means that they are much more than the proton. So you see, this is also the differences number 2. And the differences number 3 is said that it have more proton than electron. So you see, the positive charges, it always have more proton in it than the electron, and the negative ion, it have more electron than the proton. So you see, this is there also the differences. And let's see the side difference. The side difference, it says that we use a plus mark, and that is all a sign. So you use a plus sign when writing the positive ion. So you see, this is also there are differences. For the positive charge or positive ion, we use a plus sign or a mark. This means that it's an indicator that this one is a positive ion. And the negative ion is we use the minus mark or the minus sign for us to identify that this one is a negative ion or negative charge. So this is the differences. This is the differences between the positive ion and the negative ion. Okay, so the third content for the physics class for SS3 student week 5 is also to differentiate between the conductors and the insulators. So before we even differentiate them, we have to explain, or I have to show light on about the conductor and the insulator before you even go to their differences, because the content it not specify that we shall know the meaning or that is the example of the conductors and the insulators. So normally when we say conductors are devices that allowed electric current to pass through them. That is the conductor. So example of conductor, it can be like a metal. A metal is a very very good conductor. It allowed current or electricity to pass through them easily. Also like a silver also is an also example of a conductor. It's allowed a current, and when we say current, we are talking about the electric charge. It allows the electric charge or the electricity to pass through them easily. Also a silver or aluminium, they are also example of conductors. So let's talk about the insulator. When we say insulators, we are talking about those devices that do not allow current to pass through them easily. So you see, this one are the insulators. They do not allow electric current or a current or electricity to pass through them easily. So example of them, like it can be like a paper. A paper is a example of insulator. Like a glass. A glass is an insulator. So you see, they do not allow current to pass through them. And also a rubber. A rubber is a very good example of insulator, because they do not allow current to pass through them easily. So let's see the content here. It says we are to differentiate between them, between the conductors and the insulators. So the differences between the conductor here, for the conductor we have a conductor allowed current to pass to follow easily through it. So you see this is also like the meaning or the definition of the insulator. Okay, for the conductor, sorry. And for the insulator it says an insulator do not allow a current to flow through it. So you see also they do not allow the flow of current or electric charge to flow through them. So this is also the number one, a very good difference between them. And also let's see the difference number two. It says electric charge exists on the surface of conductor. So you see the electric charges, it exists. So when we say it exists, that means that they are present, they exist there on the surface of of conductors. And for the insulators we have electric charges are absent in insulator. So you see that means that there is no electric charges in insulator. This is also a very good example between the conductors and the insulator. And the third example between them, we have that conductors don't store electric charges when kept in a magnetic field. So you see the conductors, they don't used to store charges, they just allow them to pass through it in when kept in a magnetic field. So when a situation of the magnetic field, the charges, the electric current, it is not stored, all the power, all the energy is not stored on it, on the conductor. But let's talk about the insulator. The insulators store energy when kept in a magnetic field. So you see the energy inside there, it is kept in a magnetic field. So you see the energy is there in the case of insulator. So this is also the difference between the conductor and the insulator. So let's talk about the fourth differences. The thermal conductivity heat allowances of a conductor is very high. So you see the conductivity or the thermal conductivity, that is the heat allowance of a conductor, is very high. So you see it is high, but for the insulator is very low. So you see this is the thermal conductivity of them is, for the conductors is very high, but for the insulators is very low. So the last one is that the resistance of a conductor is very low. So this one we are talking about the resistance of the conductor is very low, but for the insulator the resistance of the insulator is very high. So this is also a very good differences or difference, how they come to differ between the conductors and the insulators. So this is about the differences between these two. So here we are to talk about or to explain the golf leaf electroscope. So the golf leaf electroscope is a synthetic electroscope type that is used for detecting charges. It consists of a brass rod with a brass disc at the top, and at the bottom there are two thin golf leaves in the form of foils. In order to keep the rod in place, the rod travels through the insulators. So let's check the explanation here. It says that it is a electroscope, and when we say electroscope, it is an instrument used for detecting charges or to identify whether the charges is a positive or a negative charges. So this means that this instrument is used for detecting charges, whether the charges it is a positive charge or a negative charge. So this is how this instrument is, and it says that the golf leaf electroscope is a synthetic electroscope type that is used for detecting charges. So you see also it is used for detecting charges or determining or identifying charges. So it consists also it consists, as you are seeing here at the top, it has a brass desk. So this is where we have the brass desk, and we also have the insulator plug, also the bottle, that is the whole bottle of the electroscope. And we also have the brass rod, and also this brass rod, you remember there are two, because there are two in number. The For the detecting of the charges, it is using two golf leaf, that is the two brass rods. And there, and at the left side, it is the metal fuel there, and that is the earth, that is the ground. That is how the to determine, for the determine of the electric charges, whether it is a positive charge or a negative charge. So this device, normally it is used for detecting charges. This is the importance of this device. That is how the device look like, and this is the like the labeling of the device, how the device used to be, or the use of the device. So this is how is it. This is about gold leaf electroscope. So I think this is the end of the week 5 lesson for physics student, to the SS3 student. So I wish you best of luck. Thank you for listening.